This video is going to cover the objective of calculating pH, pOH, hydrogen, and hydroxide concentrations of acids and bases. So remember that pH represents the power of hydrogen. The more hydrogen, the more acidic your substance is, and so it'll have a low pH, less than 7. If you have a neutral pH, then that's going to be equal to 7, and then a pH of greater than 7 is going to be basic, which would have a low hydrogen concentration. So the self-ionization of water. Water is a neutral substance, but it breaks apart or converts into the ions hydronium and hydroxide by transferring a hydrogen from one water over to its neighbor. And after doing this, this water loses a hydrogen and becomes hydroxide. This water gains a hydrogen and becomes this hydronium. And then this happens in reverse, where the hydronium transfers a hydrogen back over to hydroxide, and in that process we get again the waters that we had before. So it's kind of like the hydrogen is moving back and forth like a volleyball, and each time it moves it changes to these guys and then back to these guys. Another way to say this is that water breaks apart into its ions hydrogen and hydroxide. So H3O plus in brackets is the hydronium ion. And I need you to know that hydronium and hydrogen are the same thing. They represent exactly the same thing. This is just the short version of this one. Note that the brackets means the concentration of in molarity. So if you were to take the amount of hydronium ions in a solution and multiply it times the amount of hydroxide ions in the solution, they should equal a constant. 1 times 10 to the negative 14. This number is a constant. It cannot change. Therefore, if you change the amount of hydronium, then you're going to subsequently change the amount of hydroxide in the solution. So brackets mean the concentration of in molarity. So the concentration of hydronium times the concentration of hydroxide should always equal the same thing, 1 times 10 to the negative 14. So water is neutral. It has a pH of 7. That means that the amount of hydronium and the amount of hydroxide are equal to each other. And you can write that like this, or you can write it like this. It means the same thing. Notice that sometimes H plus is used instead of H3O plus for the positive ion. So it's also good to note that when you have a solution that has a greater amount of hydrogen than there is hydroxide, this is when it becomes acidic. And if the solution has a greater amount of hydroxide than the amount of hydrogen, the solution is considered basic. So now we're going to do some calculations. You might be asked to calculate the pH, the pOH, the hydrogen, or the hydroxide. And you have several different equations at your disposal. So I'm going to show you how to use each of these 6 equations now. First, we'll focus on pH plus pOH equals 14. So if I have a pH of 8.5, what is the pOH? So first of all, we recognize that the equation we want to use is pH plus pOH equal 14. Then plug in what you know, and they tell us we have a pH of 8.5 plus, I don't know the pOH, but I do know that together they equal 14. And so to solve this, you're going to take 14 and you're going to subtract 8.5. to get your answer. So the pOH is going to be equal to, and we'll say 14 minus 8.5, and that gets us 5.5 as the pOH. Let's look at another example. What if the pOH this time is 9.3? What's the pH? So we're going to take pH plus pOH equals 9.3. So we're going to say pH plus pOH equals 14 is the equation I want to use. I'm going to plug in what I know and what I don't know. I don't know the pH, but I do know that the pOH is 9.3, and together they should equal 14. So to solve this, I'm going to subtract 9.3 from both sides of the equation, and that means that the pH is going to be equal to, and I do 14 minus 9.3, and that gets us 4.7. All right, now that you know how to use that first equation, let's do the second equation. So the question is, if the hydroxide concentration is 2.8 times 10 to the negative 4, that's this right here. What is the hydronium concentration that is the same as this right here? So we have our equation, hydrogen times hydroxide equals 1 times 10 to the negative 14. Let's plug in what we know and what we don't know. We don't know hydrogen, but we do know that the hydroxide is 2.8 times 10 to the negative 4, and that equals 1 times 10 to the negative 14. So to solve this, I want to isolate hydrogen. I'm going to divide both sides by 2.8 times 10 to the negative 4. That's how it will cancel on this left side. And so type it into your calculator as this fraction right here. So we're going to click A over B. At the top, we'll put 1 times 10 raised to the negative 14. And at the bottom, we'll put 2.8 times 10 raised to the negative 4. And you can see over here we have our answer. So we'll round it off. The hydrogen concentration is equal to 3.57 times 10 to the negative 11. Be sure you keep that exponent at the top. Let's try another example. So we're using the same equation. We have the hydrogen times the hydroxide is equal to 1 times 10 to the negative 14. And they're telling us this time that hydrogen is 1 times 10 to the negative 6, and what is hydroxide? So I'm going to plug in for hydrogen 1 times 10 to the negative 6. I don't know hydroxide, and they should together equal 1 times 10 to the negative 14. So if you saw last time, we just had to divide both sides by our given in order to get our answer. So it's going to be this is going to equal my hydroxide. So I'm going to click on A over B, 1 times 10 raised to the negative 14 over 1 times 10 raised to the negative 6. And that's going to give us 1 times 10 to the negative 8. And that is our hydroxide concentration. Now we're going to use these two equations. pH equals the negative log of hydrogen, and if I want the hydrogen, it's equal to 10 to the negative pH. So in this problem, I'm asked, what is the pH? So I want to use pH equals, because this will solve for the pH. So the equation is pH equals negative log of the hydrogen concentration. So what I want to know is, what is the pH? I'm going to take the negative log of the hydrogen concentration, which they give me here, 1 times 10 to the negative 6. 1 times 10 to the negative 6. So when you plug this into your calculator, this is going to be a little bit more challenging and involved, but not too much. We're going to come over here, we're going to hit negative. Go to function, click log, go back to main, and then type in 1 times 10 raised to the negative 6. Don't forget to close your parenthesis, and we get that the pH is equal to 6. Here's another example. This time, if the hydrogen is 3.8 times 10 to the negative 11, what is the pH? Since I want the pH, I'm going to use the pH equals the negative log of the hydrogen concentration. Remember, H plus and H3O plus are the same thing. So I'm going to plug in pH equals negative log of, and they tell me that the hydrogen is 3.8 times 10 to the negative 11. 3.8 times 10 to the negative 11. Now it's just a matter of typing this into the calculator. So we'll come over here, we'll hit negative, go to function, log, go back to main, type in your number, 3.8 times 10 raised to the negative 11. Don't forget to close the parenthesis, and we get 10.4. So this has a pH equal to 10.4. Good to note that that is a basic pH, now that we have calculated it. Now it's going to appear like we're doing the reverse. If we have the pH is 3.8, what is the hydrogen concentration? So I want to use this equation, which will solve for hydrogen. The hydrogen concentration is equal to 10 raised to the negative pH. And so in order to type this in, we're going to fill out our equation, H plus equals 10 raised to the, and they give me the pH is 3.8. So raised to the negative 3.8. So to type this in our calculator, we're just going to type 10 raised to the negative 3.8. And that gives us a hydrogen concentration of 1.58 times 10 to the negative 4. One last example of this, if the pH is 6.5, what is the hydronium concentration? So since I want this, I want the equation that's set to solve for hydronium or hydrogen. H plus is equal to 10 to the negative pH. And so I'll plug in, here's my equation, 10 raised to the negative 6.5. And so now I'll just type this into my calculator, and it's going to be 10 raised to the negative 6.5, and then we get our answer. The hydrogen concentration, or hydronium, is 3.16 times 10 to the negative 7. So the calculations that we just did should also work for these two equations. pOH equals negative log of hydroxide, or hydroxide is equal to 10 raised to the negative pOH. Just these are the same. The only difference is instead of pH, it's pOH, and instead of hydrogen, it is hydroxide. So we have a little box here just to kind of show you that you can have one-step calculations, or you might have two-step calculations. For example, if I have the pH but I want the hydroxide, I'm going to have to calculate from pH, maybe I get the pOH, and then from the pOH I get the hydroxide. So now we'll do some practice in class.